Hello guys! In this chapter, we are going to talk about multiple modeling of systems in Simulink. Multiple modeling means that we can model the systems with different methods in the Simulink. For example, when you have the state space equation matrices, it's not necessary to convert it to transfer function or vice versa. When we have mathematical equations of a system, we can find its model and implement it in the Simulink or MATLAB. In this regard, the first method is modeling with standard blocks. What we have done so far, when we had an equation, we simulated it in the separate blocks. We simulated it in separate blocks. If you remember, s to the power 2 plus 2s plus 1 was simulated with two integrator, a sum, and step blocks. But it is not the only way. The next method is state space or ABCD matrices. I will explain it in the next slide. The state space equals SS code in the MATLAB. Then we have transfer function model or TF in MATLAB, transfer function block, and function model with zero and pole or ZPK in MATLAB or zero and pole block. Let's review the methods. The first model is state space model. If you remember, we had x dot equals ax plus bu, then the y, which was our output, was y equals 6 plus du. The code of such model in MATLAB was ss. Then we have transfer function. Then we have transfer function. As you know, it equals outputs divided by inputs. Its code in MATLAB is TF. The third is zero pole. When we have a system, its zeros and poles are available. We can simulate it in Simulink and MATLAB with ZPK code. When we have a system, its zeros and poles are available, we can simulate it in Simulink, and also we can simulate it in MATLAB with ZPK code. As you know, 0 is the root of numerator, pole is the root of denominator, and we have gain. Fourth is a block modeling, which I had explained it before. Okay, let's go to the MATLAB. I want to show the models here. I want to define ABCD matrices. After defining them by SS code, I want to define the system's state space equation in MATLAB. As you can see, the MATLAB has defined the matrix's state space equation. Now I can separate any of these matrices. It means that I want to consider the inverse mode of it. In doing so, for example, to find matrix A, you can type A equals F times A, or for matrix C, or you can use this code if you want all of these matrices. It defines all of the matrices. in Simulink, you can define the state space equations too. It is very easy. But before going to Simulink, I want to show you other codes. We have TF code, which is for specifying transfer function, or even we can specify a new transfer function for two matrices, one numerator matrix and other one the denominator matrix. Also, we have ZPK function, which is for zeros and poles of the system. Suppose that we have a system and it's -4 divided by s minus times s plus 3. If we want to show it with ZPK code, for example, I type these terms. Because we just had s in the numerator, so we had a 1, 0. It means that roots of the numerator are 0 and there are two roots in the denominator, 2 and -3, and the gain was -4. Now you can see that we had created the function of 0 pole. Okay, it was all about MATLAB. In the next episode, we will work on Simulink.